Hello children, how are you all? Hope you all are doing well. This is VKM. Welcome to Electron Chemistry Center. In last lecture or in the previous lecture, we had discussed about nitric acid preparation and properties. Hope you have revised it. Very important concepts we have discussed. Now in today's lecture, we are going to talk about oxides of nitrogen. Children, nitrogen can form various oxides like N2O, NO, N2O3, NO2 or N2O4, it's a dimer N2O4, N2O5, nitrogen pentoxide. So these are the various oxides which are formed by the nitrogen when it reacts with oxygen generally, right? So we are going to talk about the preparation and properties of these oxides and oxides of nitrogen, as well as we are going to talk about structure of oxides of nitrogen, right? So before going to the video, if you like the video, please click on the like button and please watch till the end. You will get a better idea. If you haven't subscribed to my channel, please subscribe it, and if you have already subscribed, please click on the bell icon, right? If you have any doubts, you can post in the live chat or you can post in the comment box after the premiere. Okay, we will discuss oxides of nitrogen. And now there are 5 oxides majorly. First one we have N2O. This is called as nitrous oxide. Nitrous oxide, commonly also known as laughing gas. Also known as laughing gas because it causes laughing hysteria if it is inhaled. If it is inhaled, it causes laughing hysteria. For suppose if it is overdose, it may leads to the hazardous effects, so it may be fatal. So N2O, in which nitrogen oxidation state is +1, right? And how it can be prepared? It can be prepared by heating NH4NO3. In lecture 2, I think so, I have told you, lecture 2 or 3, I have told you the shortcut also. Ammonium nitrate, remove maximum number of water molecules, 2 2s are 4, 4 hydrogens and 2 oxygens, still one more is there, oxygen, so N2O you will get it. So simply decomposition of ammonium nitrate will give you N2O plus H2O. Is it clear for you children? Similarly, we had discussed a few reactions in the last lecture also, that is properties of nitric acid. When zinc is reacting with nitric acid, nitric acid, it also gives you N2O. Okay, it also gives you N2O, that is zinc plus, of course, cold dilute HNO3 will give you zinc nitrate ZnNO3 twice plus N2O plus H2O. I have not balanced it, right? So we can prepare by treating metal like zinc with HNO3. That is also another preparation method can be given. And physical appearance and chemical nature, if you observe it, it is a colorless gas but neutral. It is a colorless gas but neutral to the litmus, right? So let's see the second oxide. Second oxide is nitrogen monoxide or nitric oxide or nitrogen 2 oxide, and formula is NO and oxidation state is +2. Oxygen is -2, nitrogen is +2. Clear children? And if you see the preparation method, how can you prepare the nitric oxide? Nitric oxide can be prepared by treating sodium nitrite, NaNO2, sodium nitrate with freshly prepared acidified ferrous sulfate, FeSO4, then upon adding H2SO4, it will give you nitric oxide. So here, if you take NaNO2 and treat it with FeSO4, it gives you Fe2SO4 thrice plus 2 NaHSO4 plus 2 H2O plus 2 NO. It is one preparation method. Okay, it's not sodium nitrite, it is sodium nitrate, NaNO3. Sorry, NaNO3. This is a reaction you can observe it in Brown rings test. It is a reaction observed in Brown rings test, children, right? So similarly, this nitric oxide can also be prepared by catalytic oxidation of ammonia. By catalytic oxidation of ammonia. Hope you remember in the last lecture we had discussed about this. It gives you NO plus H2O. Catalytic oxidation of ammonia gives you nitric oxide. It is the raw material for the preparation of nitric acid in Ostwald's process. Okay, let's see the chemical nature and physical appearance. Colorless gas it is also, and neutral. It's an example of a neutral oxide. It is an example of a neutral oxide. Now, if we see the next one, that is dinitrogen trioxide or nitrogen 3 oxide. Formula is N2O3 and oxidation state is +3. Oxidation state is +3, children. So, how it can be prepared, that you can see under preparation method. So, whenever this NO combines with N2O4 at 250 Kelvin, it gives you N2O3, nitrogen trioxide, and this nitrogen trioxide is also called as nitrogen oxide. Nitrogen oxide. Okay. So now similarly you can prepare N2O3 by combining nitric oxide and nitrogen dioxide. By combining nitric oxide and nitrogen dioxide will give you N2O3. And the chemical nature, it is an example of a blue color solid. It's a blue color solid and it is acidic in nature. It is acidic in nature, and NO plus NO2 combining together to give you N2O3. The same combination of NO plus NO2, this mixture of two oxides of nitrogen, also can be formed by treating, I am writing on the top, treating copper with HNO3. Copper with HNO3. So it also gives you NO and NO2 mixture. NO and NO2 mixture will be formed along with the copper nitrate and water. So NO plus NO2 gives you N2O3. Understood? So this N2O3 is an example of a blue colored solid. Okay, it is an example of a blue color solid. Now next, if you see NO2, nitrogen dioxide, and nitrogen oxidation state is 4 in this oxide. So that's why they have written nitrogen 4 oxide. NO2 is the formula. Oxidation state of nitrogen is +4. Very important preparation method. Thermal decomposition of lead nitrate will give you 4NO2 plus PbO plus O2. They will ask you to write down these products, right? So they will give you blanks and they will ask you to find it out the products. So thermal decomposition of lead nitrate. Thermal decomposition of lead nitrate gives you NO2, nitrogen dioxide plus PbO plus O2, right, upon heating up to 673 Kelvin. And it is an example of a brown gas and acidic in nature. And next, dinitrogen tetroxide or nitrogen 4 oxide. Nitrogen 4 oxide, it's a dimer of nitrogen dioxide. Nitrogen dioxide dimer it is. So oxidation number is +4, and generally this NO2, if it is undergoing dimerization, it gives you N2O4. Generally NO2, if it is cooled, it will undergo dimerization, gives you N2O4, and it is a colorless solid or liquid, and it is acidic in nature. The last oxide we have, and this preparation method is also very important, that is dinitrogen pentoxide. Formula is N2O5, in which nitrogen oxidation state is +5. As oxidation state of the central atom increases, acidic nature also increases. So that is the reason N2O5 is the most acidic oxide compared to the other oxides in another way. So it can be prepared by treating nitric acid with P4O10. Nitric acid, whenever it is treated with P4O10, it gives you metaphosphoric acid. Formula is HPO3 and N2O5. Nitrogen pentoxide will be formed, and it is a colorless solid and acidic in nature. Colorless solid and acidic in nature. Hope you understand. Is it clear for you? So there are majorly the oxides of nitrogen are N2O, NO, N2O3, NO2 or N2O4 dimer, of course, and next one we have N2O5. These are the oxides of nitrogen we have. Hope it is clear, children, right? Then we will move on to the next topic, that is oxides of nitrogen only. We will be elaborating the each and every point of every oxide of nitrogen. Okay. Now we will talk we'll talk about properties of each and every oxide of nitrogen. The first oxide of nitrogen we are going to talk about, it is dinitrogen oxide, N2O. It is also called as a laughing gas, as if you inhale it, it produces laughing hysteria. That's why it is said to be laughing gas, children. It is a colorless gas, as you know, and it is having a pleasant smell and sweet in taste. Okay, it is having pleasant smell, it is having pleasant smell and sweet in taste. Okay, in which all electrons are paired. That's the reason it is an example of a dimagnetic oxide. It is an example of a dimagnetic oxide. If you observe the structure here, if you observe the structure, so in this structure, if you observe it, N triple bond N and lone pair on nitrogen donated to oxygen, it forms a dative bond. And if you write the resonance structure of it, right? Resonance structure, if you write it, it is gaining the negative charge and it is gaining the positive charge, right? So, and N double bond N and double bond O, and it is forming more number of bonds. That's why it is having positive, and less number of bonds, it is a negative, children. Is it clear for you? So if you observe that N double bond N double bond O, it is sigma pi and it is sigma pi, and this N2O is an example of linear unsymmetrical molecule. Linear unsymmetrical molecule. I am telling you once again, children, the points whatever I am writing here, which are not there in the presentation or which are not there in the PPT, are very, very important. Please, you should make a note on it. Those points are very important for the competitive. N2O is linear unsymmetrical molecule, and it is isoelectronic, with CO2. Hope you know the what is meant by isoelectronic. Isoelectronic means the species which are having same number of electrons. N2O and CO2 both are having same number of electrons. Both are having same number of electrons. That's the reason those are isoelectronic species. So structure, it is a structure of the N2O. Is it clear for you, everyone? Okay. So now let's talk about second one. We have nitrogen monoxide or nitric oxide, and formula is NO. Formula is NO, right? So it is the most stable oxide of nitrogen. N and O together have 11 valence electrons. So nitrogen is having how many outermost electrons? 5 outermost electrons, means valence electrons. Oxygen is having 6 valence electrons. So total together 11 valence electrons are present. So that's why that indicates it is an example of odd electron molecule. One electron which is unpaired. So because of the presence of unpaired electron, it is an example of a paramagnetic substance. It is an example of a paramagnetic substance, children. It is paramagnetic due to the presence of unpaired electron. Sometimes they will ask you like which of the following is paramagnetic oxide or which of the following is diamagnetic oxide. In such cases, you have to remember it. Is it clear? So the best use of nitric oxide, as I told you, used in manufacture of nitric acid. Used in manufacture of nitric acid by which process? By Ostwald's process. By Ostwald's process, we can manufacture nitric acid by the help of nitric oxide. So it acts as an oxidizing as well as a reducing agent also. If you observe it carefully, so it is a structure. There is a possibility of two structures for nitric oxide. One is ionic structure, another one is covalent structure. Another one is a covalent structure. That ionic structure, if you observe it, ionic structure, so the nitrogen is having double bond with oxygen. Double bond with oxygen. Oxygen 2 bonds anyway has been formed, and 2 lone pairs it is to have. It is one lone pair that you can see. It is one lone pair, Another lone pair, short of one electron, that's a plus charge, excess of one electron, that's a negative charge, right? Or else you can write it as N double bond O. Oxygen is retaining its lone pair and nitrogen is having only one electron. Generally nitrogen is having 5 valence electrons, 1, 2, and here 3, and here 4, and here 5. Due to the presence of this odd electron, it is paramagnetic in nature. It is paramagnetic in nature. Hope you understand the point. And similarly, in liquid or solid state, if you observe, NO can form a loose dimer. It's a dimeric structure. So I am writing that point here. In liquid or in solid state. In liquid or solid state, NO forms loose dimer. NO forms loose dimer. Dimer formula is N2O2. And this N2O2, it is diamagnetic in nature. It is diamagnetic in nature. Why? Because unpaired electrons gets paired up. That's the reason. Okay, it is diamagnetic in nature. So if you observe it, and it is having 2.4 angstroms bond length, and it is having around 1.10 angstrom bond length. So this dimeric structure of nitric oxide is possible. Dimeric structure of nitric oxide is possible in liquid or solid state. NO forms a loose dimer. NO forms a loose dimer. Hope it is clear. So very important points we are discussing. Please make a note on it. And let's talk about next one. That is nitrogen dioxide. Nitrogen dioxide, it is an acidic oxide and it is a reddish brown gas. It is a reddish brown gas. Generally, this reddish brown gas, children, if it is cooled, it's around minus 11 degrees Celsius. If it is cooled, it gives you a colorless solid. It gives you a colorless solid, that is N2O4. A reddish brown gas NO2 can be cooled into N2O4. Means it is undergoing dimerization. It is undergoing dimerization. So that's the reason we got a colorless solid. The dimer is nothing but N2O4. Okay. It is also paramagnetic in nature. As I told you, it is dimerized to N2O4. So the paramagnetic nature that you can understand with the help of structure. Let me explain the structure in detail. This NO2 structure, if you observe it, nitrogen dioxide structure, if you observe it, children, carefully. Nitrogen dioxide structure, if you observe it. So here I am writing simple structure that nitrogen forms a double bond and one odd electron is present, gives its lone pair to oxygen. That you can observe it here. These two structures which are equivalent resonance structures, if you observe it, right? So oxygen is carrying 3 lone pairs. Oxygen is carrying 3 lone pairs. So I am giving here a dative bond, then it is correct. Similarly, if it is in resonance, then double bond it can be written here and it is a dative bond. So this odd electron is responsible for the paramagnetic nature of nitrogen dioxide. This odd electron is responsible for paramagnetic nature of the nitrogen dioxide. Is it clear? So if you elaborate the structure, and the structure, if you observe it, it is a V-shaped molecule. It is a V-shaped molecule in which, if you observe that angle is ONO bond angle is 134 degree and NO bond length is around 120 picometer. In few books they give you 124 also, that is also correct. That's why we are taking around 120 picometer. Hope it is clear. Yeah, it's a very important question even for board examination also. Why does NO2 dimerize? NO2 generally contains odd number of valence electrons, just now we have discussed. It behaves a typical odd molecule. On dimerization it becomes more stable. That's the reason it has to dimerize. For suppose if it undergo dimerization, it is converted into stable N2O4 molecule with even number of electrons. So N2O4 is more stable. N2O4 is more stable. That's the reason it can be converted into stable N2O4 by dimerization. Okay. So before going into the dinitrogen trioxide, I should talk about another point here. Nitrogen dioxide, when it is dissolved in water, very important point, please make a note on it. 2NO2 plus H2O, it gives you two acids, nitrous and nitric acid. So mixture of nitrous and nitric acid. So a mixture of nitrous and nitric acid, it is nitrous acid and it is nitric acid. A mixture of nitrous and nitric acid can be formed by treating this NO2 with cold water. That is the reason NO2, it is a mixed anhydride. These points are very important for competitive children. It is a mixed anhydride of HNO2 and HNO3. HNO2 and HNO3. Especially in match the following, they used to give these type of questions. NO2 is a mixed anhydride of nitrous and nitric acid. Hope it is clear for you, and structural aspects also clear for you. Okay, please make a note on it. I am erasing it. And now let's talk about next oxide, that is dinitrogen trioxide or N2O3. It is also an acidic oxide. It is also known as, I have told you, nitrogen sesquic oxide, also known as nitrogen sesquic oxide, and it is diamagnetic in nature. There are no unpaired electrons. That's the reason it is an example of a diamagnetic molecule. If you observe carefully, you can write two structures. Very simple to remember. On both sides of oxygen, N double bond O, N double bond O is there. So N2O3, this is nothing but symmetrical form of N2O3. Symmetrical form of N2O3, or you can write it as asymmetrical form, N double bond O and now N double bond O and O. So it is asymmetric form. This form is asymmetric form. So this asymmetric form is planar in structure. That asymmetric form is planar in structure. And double bond, single bond, double bond, there is a conjugation. That's why you can write it resonance structures. This asymmetric form of N2O3, you can observe it here. This is also asymmetric form. This one. This is also asymmetric form. See, check it carefully. N double bond O. Okay, connected with another N. That is connected with double bond O, connected with O. Okay, it is a planar structure that you can see it here. And bond angle and bond length aspects, okay, you can check it over here. Bond angle and bond length aspects also you can check it. So here it is double bond O, it is dative bond N, and it is double bond O. Right? This bond angle is 105 degree. This bond length is 114 picometer. This bond length is 186 picometer. This bond angle is 130 degree. Two bond angles are possible. And another bond angle here, this one. This is 117 degree and this bond length is 121 picometer. But these aspects, okay, they won't ask, but generally for information purpose we are giving it. Is it clear? Hope you understand that, right? It's a planar molecule, just now I have told you. So dinitrogen tetroxide, that is N2O4, it is formed by dimerization of NO2. We had discussed a question also, why does NO2 dimerize? Right? It has no unpaired electron on an atom. It is diamagnetic. It is a diamagnetic. The structure also you can observe it here. The structure also you can observe, and resonance structures also you can observe it. Right? N2O4. It has been dimerized. So this can be given as a dative bond. This also can be given as a dative bond. And it is a dative bond, and it is also dative bond. Why? Because double bond, single bond, double bond is there. So conjugation is present, so it is undergoing resonance. And bond parameters also you can check it. N bond length is 176 picometer. Just it is a representation of the molecule. It's not actual molecule. It's a representation of the molecule, and this bond angle is around 135 degree. Hope it is clear for you. Right? Check it carefully. It is also a planar molecule that you can observe the structure. Dinitrogen pentoxide, and the most unstable acidic oxide, and moreover it is an example of, best example of the oxidizing agent also. Nitrogen pentoxide, it is an example of oxidizing agent also, right? You can check the structure carefully. NON. Generally No other oxide of nitrogen has NO-N bond here. In between N and N is O, okay, is present for this. Other, if you observe it, which is connect in that, in case of asymmetrical form or asymmetrical form also, one NO-N bond will be present in that N2O3 structure, and next one is N2O5. These two oxides generally will have NON, and N double bond O, single bond O, it is O, that means it is dative bond. You can write it as dative bond. This is also dative bond. Is it clear for you? The structure is in resonance. The structure is in resonance, right? Resonance structures can be represented. And now this X-ray studies reveals that X-ray study says that solid N2O5, solid nitrogen pentoxide, is existing as nitronium ion, that means as NO2 plus as well as NO3 minus. It can be existed as NO2 plus and NO3 minus. Generally, the type of questions how they used to ask, in solid state of N2O5, the hybridization of N in those species. The species they won't give it, but you should understand that in solid state N2O5 can exist as NO2 plus and NO3 minus. You have to find it out the hybridization. Okay, so when you take N2O5, N2O5 dissolves in water, it forms nitric acid. N2O5 dissolves in water, nitric acid. It's a non-metallic oxide, dissolves in water, it gives acid, ic acid. That's the reason it is an acidic anhydride of, it is an acidic anhydride of HNO3. Means if you remove water from nitric acid, it gives you N2O5. That's the reason N2O5 is an acidic anhydride of HNO3. Is it clear for you? It's a very, very important. If I take N2O3 when I dissolve it in water, it gives nitrous acid. That's why N2O3 is acidic anhydride of nitrous acid. Acidic anhydride of nitrous acid, whose formula is HNO2. Whose formula is HNO2. Is it clear for you? Right? So I told you it is an example of excellent oxidizing agent. It is an example of excellent oxidizing agent. It can oxidize so many organic substances, and it also oxidizes iodine readily into iodine pentoxide. Very important reaction, children. N2O5, when it reacts with I2, it gives you I2O5 plus NO2. I2O5 plus NO2. I'm trying to balance it. It's fine, I think so. 5, yeah, 10 NO2. So iodine can be oxidized to I2O5 by the help of nitrogen pentoxide. Hope it is clear for you, right? These are all oxides of the nitrogen, and bond angle and other aspects you can check it here. 120 degree and here around 134 degree. There is a question. What is the covalency of nitrogen and N2O5? Very frequently they used to ask this question, CET or NEET. Nitrogen generally can form 3 bonds and it can expand. Okay, generally it cannot expand, but nitrogen atom has a shared electron pair, so the covalency can be given it as 4. Means 1, 2, 3, 4. One bond here it is formed with oxygen, it has donated its lone pair, hence covalency can be taken it as 4. Understood? Don't write it as 5. Nitrogen oxidation state is +5. In which compound? N2O5. Right? But whereas covalency is 4. In which compound? Covalency is 4 in which compound? N2O5 only. Observe the difference carefully. Is it clear? What is the covalency of nitrogen means? That is the answer should be given. Tell me the answer. Which is also called as laughing gas or laughing grides? Which is also called as laughing gas or laughing grides? Check it carefully. Very simple question. What is the answer? Nitrous oxide, N2O. NO is an example of paramagnetic oxide because of the presence of one unpaired electron or odd electron. NO2 is reddish brown gas, while N2O4 is colorless gas or solid. NO2 is paramagnetic while N2O4 is diamagnetic. So option A is the correct answer. So I told you, as per topic, oxides of nitrogen is over. Now we will be discussing about oxides of phosphorus here only, not as a separate topic. Oxides of phosphorus also I will be discussed here only. I will be discussing here. Generally, very important oxides only we will be discussing, not all the oxides. Okay, not all the oxides. Very important oxides only we will be discussing. Very important oxides are trioxides and pentoxides. Dimeric form is P4O6, dimeric form is P4O10. P2O3 dimeric form is P4O6, P2O5 dimeric form is P4O10. It is phosphorus trioxide and it is phosphorus pentoxide. Understood the point? So let's talk about first one, that is P4O6. Generally we will discuss structural aspects in dimeric form only. How it can be prepared? It can be prepared by treating or burning of phosphorus in limited supply of oxygen gives you P4O6. Gives you P4O6, children. It's a very important acid. Okay, so it's a very important acidic oxide. If you check the properties, P4O6 phosphorus trioxide dissolves in water slowly, dissolves slowly in cold water. It forms phosphorus acid. It forms a phosphorus acid, that is with cold water. But suppose if it is with hot water, a violent reaction is noticed that gives you phosphoric acid. Orthophosphoric acid also will be formed. So P4O6 with hot water, phosphorus trioxide with hot water gives you orthophosphoric acid and phosphine gas. Orthophosphoric acid and phosphine gas. H3PO3, that is phosphorus acid. H3PO3, that is phosphorus acid. Is it clear? Now the most important is structure. Structure of P4O6. Most of the times the questions in competitive examinations used to be based on the structures of P4O6 and P4O10. What type of questions they will ask you, right? If you check the structure, it's very simple. Four phosphorus are over. Now one oxygen is pending. Right? Simply, okay, four phosphorus atoms with oxygens. Four oxygens are over. Still, two more oxygens are there. So this is linked like this, okay, and it is linked like this. Phosphorus can form maximum how many bonds? 5 bonds, right? Yes or no? 1, 2, 3. Every phosphorus has formed only 3 bonds, so still 2 electrons are remained on phosphorus. Oxygen anyway, it is having 2 lone pair of electrons. That you have to represent here. 2 lone pair of electrons on every oxygen atom. So total how many oxygen atoms are there? 6 oxygen atoms are there. They will ask you a question in such a way like that, right? So how many POP bonds are there? How many POP bonds are there? Such type of questions they will ask you. You have to count it. Okay, like this, POP bond. 2, okay, 3, 4, and it is 5, 6. There are 6 POP bonds. Similarly, how many PO bonds are there? How many lone pair of electrons on all atoms? How many lone pair of electrons in all oxygen atoms? Such type of questions they will ask you. It is a very important structure. Simply start with phosphorus, bonding with O, and then alternative phosphorus are linked together by oxygen atoms. Is it clear? So that is structure of the P4O6. Hope you are following it. Clear? Now let's talk about phosphorus pentoxide. Its dimeric form is P4O10. P4O10. So generally with excess of air, when this phosphorus is burnt in excess of air, it produces phosphorus pentoxide. It produces phosphorus pentoxide. Is it clear? Right? And so if it is treated with water generally, okay, so this phosphorus pentoxide, let's talk about properties. Let's talk about properties. P4O10 treated with water. With water it gives orthophosphoric acid as a final product. This is called orthophosphoric acid. Orthophosphoric acid as a final product. And now if you take sequence of the reactions, what will happen? Sequence of reactions, if you take it, so total how many water molecules? 6 water molecules. Another important point I am going to discuss, P4O10 treated with 2 moles of water, initially it forms metaphosphoric acid. Initially it forms metaphosphoric acid, and another 2 moles of water, it gives you pyrophosphoric acid. It gives you pyrophosphoric acid. Another 2 moles. So 6 moles of water is over. So finally what will get it? 4 moles of phosphoric acid will be formed. Understood? So finally we got 4 moles of the phosphoric acid. It's very simple. Is it clear? Check it. So P4O10 we have taken. Initially with 2 moles of water, it gives metaphosphoric acid, and then pyrophosphoric acid H4P2O7, and next at last phosphoric acid, that is orthophosphoric acid, it will form. Understood? Is it clear for you? Now let's talk about structure. Let's talk about structure of P4O10. Similar structure only. Observe it. All can be linked. Right? So phosphorus can form maximum 5 bonds. Still 4 oxygens are pending. Now lone pair on phosphorus in previous structure can be utilized to form a bond with oxygen. That's all. Check it. All electrons on phosphorus has been utilized. Nothing else. But oxygen is having a lone pair. Every oxygen is consisting of a lone pair. That you can put it, okay, on every oxygen, right? So here also similarly, how many PO bonds are present? PO bonds are how many present? 4 bonds are present. Rest of the okay structural aspects are same as like that of P2O3 or P4O6. Actually it forms a dative bond. Lone pair is there, no? It gives to oxygen. It is a dative bond. It is a dative bond, you can take it. Is it clear for you? Right? So it is a structure of the P4O10, and P4O10 is a best example of a dehydrating agent. It is a best example of a dehydrating agent. So it can be used for removal of water. It can be used for removal of the water. So it is all about oxides of nitrogen and phosphorus. It's all about oxides of nitrogen and phosphorus, children. So structural aspects are very, very important. All structural aspects we had discussed. So far nitrogen part is done. Still what is pending? Phosphorus is pending. What I mean to say, in nitrogen all concepts are done. Nitrogen preparation properties, oxides of nitrogen are done. Oxides of nitrogen are done. Compounds of nitrogen we have done. Under compounds of nitrogen, ammonia as well as nitric acid we have discussed. So we need to talk about totally phosphorus. That will be discussed in the next session. Until then, take care. Signing off. If you like the video, please click on the like button. If you have any doubts, please post it in the comment box. If you haven't subscribed to my channel, please subscribe to my channel. And if you have already subscribed, please click on the bell icon for more and more videos. Bye bye.